Hello guys, so today we are here to solve this very famous problem called maximum subarray. In this problem we are given an integer array, and this integer array is it's named as nums, and we have to find the subarray with the largest sum. So what is a subarray? So subarray is a it's the continuous, it's the that let's say if we start from this index, then this is a subarray. Okay, then this also is a subarray. Okay, so subarray is continuous. All indexes are continuous in a subarray. It's a part of the original array in which all indexes are continuous. Okay, you cannot have like this is a subarray and then you can skip this middle one. So if you want a array subarray of this and you are skipping these two middle elements, that is not possible in a subarray. A subarray has to have has to be contiguous. Okay, all the indexes which are common has to be contiguous. So with this, and then the question is asking find the subarray with the largest sum and return its sum. So two things this problem is asking: find the subarray with the largest sum and return its sum. Okay, so it's asking you to find the subarray with the largest sum, okay, and return its sum. So though it's asking two things, but it's finally asking us to return only the sum value, not the original subarray as well. I mean to say the subarray which we are choosing for the largest sum, that subarray we don't have to return. We only have to return the sum value. And now to if we see this problem, then in this problem we are given a max subarray, and in this max subarray we are passed one int array nums. Okay, so int array nums is there, and then to solve this problem, see, we have to understand, okay, at every index, either we can continue with the previous sum or we can initiate a new, we can assume that the subarray is initializing from this current index itself. Okay, so either we can assume that we are continuing with the previous subarray, or we can create a new subarray from the current index. Okay, so this is the two possibility which we have. This two possibilities is the key to solving this problem. See, in any computer science problem, when you are dealing with an array or something like that, or even in dynamic programming, we assume that we are in the middle of the problem, and then somehow we are we have reached to the middle of the problem, and then we are thinking like at the middle ith index, what are the two possibilities that we have? At the middle ith index, either we can continue to have the subarray from the previous i-1 index, i-2 index, or we can create a new subarray from the ith index itself and disregard completely the previous previous subarray sum value. So in order to get that thing, what we'll do that we'll create nums.length, and then what we will do that we can create one int of max sum, okay, is equal to nums of 0, okay, and then int current sum is equal to 0, okay, and then for int I in the nums, okay, and then what we'll do, current sum plus is equal to I, okay. So I told you that either we can go with the sum with the current sum with the previous value. Suppose we are in the middle ith index, ith number is there, okay, and either we can go with the previous values of the current sum which we are accumulating in this current sum value, or we can start from the current. So what is the best that we can do? So to get that, to make that choice, we'll use this thing that we can call current sum, and then I like this, and then max sum is equal to math.max of this current sum maximum, and finally we return this maximum. Okay, so if we keep this in mind, that at the ith index in the middle of the problem, let's say the array is of size n, and it begins at the 0th index and it goes to first index, second index, third index, and somehow we are landing up in the ith index, which is in the middle of the array. And at the middle index, either we can choose to continue with the current sum value, which is accumulating the sum from the previous indexes, or we can completely disregard that previous current sum values and start a new subarray from the current index. So these are the two possibilities that we have. And this line expresses that this current sum is the previous sum values, and then we are adding the current element, and then in the current sum what we are doing max of current sum or the current ith element. Okay, so current sum is representing the sum of the all the previous indexes and the current index, or I represents only the current index. So either we can go with the option that we keep on accumulating the values from the previous indexes, or we can just start our current subarray with the current element. If we are starting with the current element, then current sum will be having the value I. If the current sum variable which we are accumulating from all the previous indexes and the current index, if that is greater, then current sum will be having that value. And then in line number 10, we are again comparing this max sum with the current sum and max sum, and whatever is the greater value is being stored finally in the maximum value at the end, at the line number 10. And finally doing this iteratively for all the elements of this array, finally at the end we are returning max sum. So max sum is the finally we are having the maximum sum value in this variable. And that's the way to solve this problem. Let's say whether this is actually solving it or not. Yeah, it's solving. So let me submit this. Perfect. So I hope this is clear to everybody. And if there is any anything which requires more clarification, please feel free to add ask them in the comments of the video, and definitely I would love to answer those comments. So the key thing to solve this problem is that at suppose the array is from 0 to nth index. Suppose the array is from 0 to nth index, and somehow we are landing up in the middle ith index value somehow, then at the middle ith index, either we can continue with the previous current sum values and include our current element with the previous current sum values, add all of these values together and move to the next index, or we can create a new subarray from the current index. Okay, and this line number 9 is key to this solving this problem. Okay, that we are telling, okay, if the current sum is greater, if the current sum means sum of all the elements from the previous indexes and the sum of the element in the current index. Okay, if the sum of all these elements is greater than the current element, okay, then we go with the accumulated sum of all the values in the current sum, or we initialize the current element. Okay, so whichever is greater, we take a choice in for that. Okay, so our choice either goes with the accumulated sum of all the previous element values and the current element value. Okay, or we can choose to start a new subarray from the current index. Okay, if you are choosing to start a new subarray from the current index, then the current sum will be having the value I. Okay, I is the current element. Okay, or if you are choosing to go with the accumulated sum of all the previous elements and the current element, then the current sum will be having the value which is there in the current sum variable. Okay, this is the key. Okay, so at every index we have two choices. Either we can go with the previous accumulated values, or we can start a new subarray from the current index. If you are starting a new subarray from the current index, then the current sum will be having the value I. Okay, and finally at the line number 10 we are choosing the max of the current sum or the max sum. Okay, and whichever is max we are storing that value in the max sum, and this we are doing till the end of the array, and in this way we are getting the maximum sum. Okay, so at every index we have two choices. First choice is either we can go with the accumulated sum of all the previous elements and the current element, or we can start a new subarray from the current index. Then we can check, then we have to check whether the whatever is the current sum, whether that value is greater than the max sum or not. If it is greater than the max sum, then we update our max sum with the current sum, or if it is not, then we let the max sum to be the maximum value. Okay, and that's how we keep on going through this array, and finally we have the maximum possible sum. So we have not found the maximum subarray which is having this sum. Okay, we have this question, find the subarray with the largest sum. This part is we have not dealt at all. We have directly gone to return its sum. Okay, and key to solving this problem is that we have to realize that at every step we have two choices. Either we can continue with the accumulated sum of all the previous element values and the current index element value, or we can choose to start our subarray from the current index itself. Okay, so if you are making this choice, then after this choice we have to realize that max sum could be either the updated current sum, or it could be the max sum which was previously stored in the maximum variable itself. So then just we have to make two choices at every index. Okay, if you are making these two choices very clearly, then we are able to solve this problem thoroughly, with a very simple application of logic. And this part we have to realize, this is the crux of this problem. If you are able to understand this thing, then this problem is solved. With this, I'm thanking you one and all. Happy coding, best wishes.